Crewton Ramone's House of Math. We're doing Trig. This is pre-cal, advanced algebra, but we're doing math. Alright, so here's what we're going to do. You're going to make me an equilateral triangle on your paper.
Okay.
And, just cause, I'm going to say it's 2, 2, 2.
Okay.
Alright?
Mm-hmm.
You draw equilateral triangle on your paper too. I'm talking to him. He's got sweet potatoes on his fingers, and he's there. You go. All right. Now, so here's what we're gonna do. We're gonna take it's just a non-scary equilateral triangle, and from that triangle, one of the basic shapes, right? And we can talk about platonic solids and all this other stuff, but one of the basic, right? Squares, rectangles, triangles, circles, ellipses. And let's see, basic parallelograms, trapezoids, and so forth. But from just this much, we're going to learn all kind of mathematics when it comes to building and. All right, so then I'm just going to cut this baby in half. Oops, that's supposed to be a straight line.
Now we have right.
Now we have two right triangles. All right, so tell you what, let's scrap one of them. Let's get rid of that. Okay, but that's all we did, is we just bisected that angle right there. Oh wait. Before we even do that line right there, let's talk about this, and that. What are the angles, interior angles of a triangle?
Oh God.
Equal to. Yeah, see, you should know this, and you're going to take notes after this, but it's fine.
60, 60, 60.
60, 60, 60, because why?
I don't know why.
Well, that's good. See, and if you're a little kid, and your little brother, I have a video on this. If I took all of these angles,
it would just make a line.
I would get 60, 60, 60, and I actually make kids. I have cardboard and stuff, and they cut it up with their and they put it down and with a piece of tape, and they make a straight line, right? Because that's 180 right there. Those three angles. All right. So the interior angles must add up to 180. There is a basic math fact, right? And that's one of those deals where that's one of those things it's very difficult to deduce, right? So I just tell you that they add up to 180. All right, so now we got that part. Oh, look, it's a design. Now I'm going to bisect my angle. Bam. So when I bisect that angle, we know all about our angles now. We know that that's a right angle, right?
Yep.
All right. And we know that that's 60 because you already told me that it was 60, 60, 60. And so what's a half of 60? Which would be that one.
30.
30. This is a special triangle. It's special. All right?
30, 60.
All right, so this is our first triangle that we're going to think, right? See, the other person I was just dealing with, we did the other triangle that isn't perfect through 30, 60, 90. We started figuring out the angles because I jumped in the middle with her. Because she's been through this before. All right, so I'm going to redraw my triangle, and I'm going to say that was 2, and this was 1. Uh-oh. What's this? Oh, wait, and I can do a couple more things. I can do that, and I can say this is the 30, and I can say this is the 60. Maybe need a little man to help us, but we'll be fine. All right, so, and if you had a piece of graph paper, see now, we'll start off with what is mathematics again? What's concept number 1 in mathematics? You should know this.
All we're doing is counting.
All we're doing is counting, right? Mathematics is study of numbers, and all we're doing is counting. All right. Now, what further when we're counting and studying? What are we studying? He just put a potato in his mouth, so now it's up to you. Relationships. That's what we're going to study, is relationships. And we're going to study these 3 to start. Okay? We're going to study sine, cosine, and tangent. All right. Those are words, and those words have meaning, right? Okay. So, what does sine mean? Oh wait. I just because you're old and stuff doesn't mean you don't get this guy, right? Sokatoa. Just remember, Sokatoa. All right.
If you're like me, that voice will be ingrained into your memory.
Until you're dead. Yes, just don't worry, just till you're dead. Alright, so way over here, I'm gonna write my, ooh look, you can even see that. Alright, so cool. So I'm gonna write so ka toa. And immediately you already know, right? You know what everybody stands for, right? So this is opposite over hypotenuse. This is adjacent over hypotenuse. This is opposite over adjacent. You see why I did this when you were little kids? Right? You know it now. It's not even an issue. Right? And with them, I just had a little man, and we'd go around the triangles and we'd talk about it, right? So now we have to. The thing with this, and this what becomes confusing for students, is that this right here is where I'm looking from if I'm looking from that 30-degree angle. All right, so katoa. Anyway, so what I have here is sine literally means the relationship between the opposite and the hypotenuse at that angle, right?
Yep.
Okay, so the way I'm going to write this using my mathematics skills is sine, and this is the thing. I'm not, you know me, I'm not big into memorization, but if you're going to memorize anything, that's the one to memorize because it'll tell you everything else, right? All right, sine 30 is the same thing as 1/2.
Because the opposite is 1 and the hypotenuse is 2.
Now, have you got a calculator handy? Or have you got a phone?
Yes, I do.
All right, so your phone and your calculator, same thing. Okay, get the super duper scientific. There you go. Turn it sideways and you're good. So funny. I had this one kid. It's like I don't have all these functions on my phone, and I was like, turn it sideways, and he was like, anyway, put in sine 30. Here, I'll do the same. I have this lovely calculator right here. I should give some of these away. I bought a bunch of these for $1.
Oh, wow.
Yeah.
Wow.
These are, I mean, that's a pretty cool calculator for $1.
Mm-hmm.
They had to close it. Yeah, that's a better calculator. There you go. So you get 0.5. So what it says, sine 30 is a number.
Yep.
Right? It's a relationship, and that number is the relationship between this and that.
Mm-hmm.
At that very specific angle, because at 35 degrees, it's no longer 1/2. Right? At 45 degrees, completely, right? Okay. You got square roots of 2 and all kinds of fun stuff going on. All right. So basically what this says, and see, this is the problem with many college students and high school students, is they remember sine 30 is 0.5. Which is true. Wrong, but true, right? Actually, it's not wrong. It's just not, you lose everything. But isn't 0.5 equal to 1/2?
Yep.
Well, there you go. There it is, right? That's that number. So 0.5 is 1/2. But see, here I lose the concept that it's 1 to 2.
Yep.
Right? And that's what we're talking about is the opposite and the, okay. So now I have 2 angles and 2 sides. And you know what? If I only had this and this, I could figure out everything on this triangle. Right? And we're only going to do like a half hour. We're going to cut it short a little bit today, and we'll pick it up again. But I just want to say that all we're going to do is study these relationships and figure out what the heck's going on. So now we got to figure out what that is right there. Now, for this one, I'm going to use our buddy Pythagoras. And then later on, we're going to come back and use trig functions to figure that out. But for now, we're going to be very accurate because we're going to use the square root sign. So, do you know what this side is?
Square root of 5?
Close. Very close. Very close. All right.
Oh.
Did you memorize it? You know, it's interesting too because you know what? You pay attention, child. He's all goofing around.
Oh.
Wait, we're gonna come to it. So we've got our friend a squared plus b squared equals c squared, right?
Yeah.
Okay. Well, that's gonna be 4 over here, isn't it? So
Yep.
that's c. And then one. I don't care which one we pick. I'm gonna pick that one to be right. It's just 1. So let's see here. What do I have here? Well, I have 1 plus some number over here. We'll call this b. Squared is the same thing as 4. Well, let's see here. Using my math skills,
B
right?
squared is 3.
B squared is the same thing as, well, hero 0, right? Subtract 1, subtract 1.
Yep.
See why we play what's under the cup from when you're 5? All right, so now I got 3. Well, then if I want to know what b is, then I just square root both sides, right? B is the square root of 3. Now I want you to notice in your mind that 3 and 5 can be numbers that get confused because your mind does not hold symbol. Your mind holds pictures.
I actually, the thing I did, I completely forgot. I did a squared plus b squared, but I treated it as like 2 squared plus 1 squared.
Yeah, there you go. So you got the 5 instead of, I get it. Because you couldn't add them. Because this was the hypotenuse. So that was your C, right? Now, if this 2 was over here, then you would have been correct, but it wasn't. And you would have had square root of 5 for that side. But, and that is a whole other triangle that we're not going to fool around with today. So anyway, square root of 3. Very accurate number. Right? Because punch your calculator, what do you get for square root of 3? That's a number you should know. Right? You should know square root of 1. You should know square root of 2. You should know square root of 3. You should know square root of 4. We know that one. That's easy. You should know square root of 5. But anyway, what's square root of 3? Punch in your calculator.
1.4422495703074008.
Are you sure?
I think so.
That's square root. Try square root 3. Let me just hit 3 and hit the square root side.
1.73.
There you go. I was having a bad time with that number. All right, hold on a second. So 3 square root. Oh, I syntaxed wrong here. Okay, all right.
What's pi in fraction form?
Ooh. Is that an honest question, or are you just being a wise ass?
No, I'm actually asking.
Wow, okay, well, very difficult to get pi in fraction form. In fact, that drove the ancients insane for the longest time, trying to figure out what pi. You can't express it in a fraction. You can get close. Chinese got very close, but yeah, it's very difficult.
So you actually can't make pi in a fraction form?
Yeah, there's no fraction, there's no 2 numbers divided by each other that would be pi, correct. Whole numbers. Anyway.
That's odd.
That's a whole. Alright, so 3, and then I hit. Wait a minute. This calculator is so strange. Square root and then the 3. Okay, fine. Which is 1.73. There you go. See, that's that. I don't know what you got there, but that wasn't it. See, and I have enough experience with numbers that I recognize the square root of 3 when I see it, and I recognize the square root of 3 when I don't see it. And I didn't see it there. So anyway, 1.7320 is about as far as you need to memorize it. I've got kids that got it memorized out to, what is it, 050808, because we live in Hawaii and 808's our prefix and so on, right? Anyway, do you need to memorize it out that far? My answer is no. We've got these things. But it comes in handy to have them. All right, so what's square root of 2, just for fun?
Square root of 2.
Here, you punch it. Hit the square root key, and then hit 2, and then hit equals.
That would be 1.41.
There you go. Now we got 1.41. I don't even know what that other number was. 1.414.
21. 35. 62. 37.
Yeah, there you go. Done.
It's as far as it.
That's as far as it needs to be.
His
His will go for days, right? Because you got that, right? I mean, and I used to have this one little kid who's great. He's a little 10-year-old genius boy, and he used to read them off until the end of the thing, right? And it'd be like, just go for days. Anyway, that's square root of 2, that's square root of 3. These are numbers you should be familiar with, at least till here. 2 is easy. 4142, that's easy. Right? 7320, that should be pretty easy also. Right? And then you can, those guys, if you want to, you can, and if you don't want to, you don't have to. Right? Okay. But you're going to get much more accurate numbers. All right, now we've got that much down. So we got square root of 3. So see, that's a much more accurate number than just rounding off to 4 places, right? I mean, that's very accurate. It's the square root of 3. Okay, so now I'm going to try and figure out and just pretend like I don't know what that one is. Okay, but I do know this angle, and I do know that side.
Mm-hmm.
Okay, so now I'm going to give you some exercises on your own if you want to, in your spare time, because I know you got so much of it. And if you don't, that's fine, right? But the idea is, start doing the calculations on all of these, figure it out, right? Because they're known. We know where we're going. So what I was saying before is like, I had one where, all right, if I know that this is 3 and I know this is 4, it's the same thing as if I know the whole thing is 18 and this side is 3. What does that other side have to be?
6.
It's gotta be 6. It can't be anything else, right?
Mm-hmm.
Okay. If I have a rectangle like this and this is square root of 3 and that's 1, this has to be 2. If I have this, it's 4 and that's 3, this has to be 5. It can't be anything else, right?
Yep.
Further, right? If I know this and that, I know that.
Mm-hmm.
Because that angle, so if I know, say, this and this, and I want a right triangle, and this is the key, it's got to be a right triangle, I know what that angle is going to be.
Yep.
Right? Because it's the relationship of these two. Or,
Yes.
well, it's the relationship, you can use any of them depending on what you want, sine, cosine, or tangent. All right, but let's just prove, or just take a look here, and say, I don't know this for the moment. But I do know that sine 30 degrees is the same thing as 1 over, I don't know what that is.
Mm-hmm.
All right, so then I punch my calculator and I see that this is 0.5. Now, if I want to get crazy, and I can be very simple, 0.5 is the same thing as a half. Well, I have half equals half, that's got to be 2.
Yep.
All right, but let's say I'm not going to be able to do that with all my decimals. So I'm going to be, I had 0.5. Now, how do I solve for x? Okay, I'm going to, dividing dandy non-difficult division has this in it, right? The use of the rectangle. So let's see here, let's just look at this again. If I have 18 and one side's 3 and the other side must be 6, then that says over here, it says 6 is the same thing. I got room, so I'm going to come down a little bit so I don't squish that. 6 is the same thing as 18 divided by 3.
Mm-hmm.
All right, so looking at this same thing here, in fact, let's just draw it here. 6 is the same thing as 18 divided by 3. All right,
Yes.
well, it seems to me that I have this one and this one, so in order to get, what do I have to do? Well, I have to multiply this times that to get this, right?
Yep.
Okay. Well, what number does that have to be? Well, can I solve this? Can you give me how to solve this? How do I set it up so I wind up with x equals?
X is equal to 1 over 0.5?
That's correct.
Yeah.
And let's do it in steps. You are absolutely correct, and you've left out all the steps because, right? Okay, so what do I have to do? I multiply both sides x, right?
Mm-hmm.
Now I've got 0.5x is the same thing as 1.
Yep.
Oh, crap. That doesn't help. I want x by itself.
So then you divide both
So I
sides
divide
by
both sides by 0.5. There you go. There's a no fun. Get back to 1. 0.5, right?
Yep.
And 1 divided by 0.5 is
X.
x. All right, I'll take it. But I'm asking you, what is 1 divided by 0.5?
2.
2.
2. Oh. Yeah. Give me a second here.
All right. So look, I just figured out that yes, that is absolutely 2, right? I didn't use Pythagoras.
Yep.
I used my sine function to figure this out. All right, I can do the same thing on all of these. I can figure. The only problem is you're going to have to recognize square root of 3 when you see it, right? Because you're going to get a decimal. You're not going to get square root of 3 on your calculator, right?
Mm-hmm.
All right. So now I can say the same. Oh, wait a minute. How about if I used? I'm still trying to find 2. See, because I know where I'm going. All right. Let's see here. And I knew my adjacent, and I knew my hypotenuse. Oh, I can't use that one, can I?
Nope.
Because I don't know that one. All right. So adjacent. Oh, wait. Yes, I can. Because I have the adjacent, but I don't have the hypotenuse. And I couldn't use this one. I couldn't use this one because I have opposite and adjacent. But can I use that one? Well, yeah, because cosine of 30 degrees is the same thing as the adjacent, which is square root of 3, and I don't know what my hypotenuse is. Right? What's cosine 30 degrees?
Let's see.
We're going to get some odd numbers, some fun numbers. But punch your calculator and tell me what cosine 30 degrees is before I get old. Hit cosine and then put in 30.
0.86602.
There you go, I like it. 0.8660. Let's just stop right there. We can keep going.
Mm-hmm.
Alright. So that means that, now what? Again, what do I got to do?
You just have to multiply both sides by
Right,
x.
right. So let's skip the steps, and then what I wind up doing, I just wound up taking that over this, right?
Yep.
Alright. What was this? Give me square root of 3, please. 1 point.
Over here.
7.
1.7320.
If I doubled this,
You'd be pretty close.
wouldn't I?
Mm-hmm.
I wouldn't be pretty close. I'd be dead on at this point, right?
Oh, yeah.
So what is this number? This number is 2.
Mm-hmm.
Right? Because how many of these are contained in that one? 2. Oh, look, we found it with cosine. We can't use a tangent, right?
Yeah.
All right. Now that's what I mean. Once you understand these principles, dude, when you see triangles and this kind of stuff on a test, you're like, yay, because it's going to be easy. All right? Because I took this one student, well, actually I've taken numerous students, but one student sticks out because recently I took that kid from 30s and 40s, right? And I mean, he had some tests like you that he got, way the hell down there in the 20s, and I don't think he ever got an 8, but he did get pretty low, right? And then the very next, 2 times, he came twice in a week. Came on a Monday and a Wednesday. Took a test on Friday. Got him all right. Teacher accused him of cheating. Because, I mean, I don't blame the teacher because the kid was getting 30s and 40s and suddenly he gets a perfect score. What the right? Oh, well, because he understood the concepts, right? Because now, if I know and I understand these principles, if I know this and I know that, well, that's going to be tangent. And I say, I can put any 2 numbers here, and you can tell me how long that is.
Yep.
Right? So our ramp begins 5 feet from the wall, right? It has a rise of 3 feet. How long is the ramp? That kind of question, right? Well, what are you going to do? Well, I use my tangent, and I'm good.
Yep.
And then further, you could get crazy, and he did that just for the giggles of it. What's that angle? Right? And he can figure out the angle because I know this and this. Right? So now we're going to do that. We're going to come backwards. And then we're going to quit. Because, like I said, it's, what is it, like 11 o'clock at night over there?
Yeah.
Yeah, see, time for you to go to sleep. I'm telling you.
Yeah.
That's it. It's the life of the college student, though.
Mm-hmm.
I can remember quite a few. Well,
Thankfully,
I'm a liar. Most of the time I spent in college, I was partying till 4 in the morning. But there were a few times where I did, in fact, study till 4 in the morning. I used to have this one roommate. He was in law. It was classic. I would leave the dorm on Friday night to go down to Waikiki, because this is University of Hawaii, and it's party central, and back then the drinking age was 18, and I would go down to Waikiki and just get in as much trouble as I could possibly get in without getting arrested. Let's put it that way. And 4 o'clock, and then that was the other thing back then too. The club stayed open until 4 o'clock in the morning, right? So I come cruising back to my hotel room, to my dorm room, and usually by foot because I would save all my money for drinks and partying. I didn't want to pay taxi fare, and it was a bit of a walk, but still. So I get home around 4:30, half-hour walk from the dorms, and I knew all the shortcuts. And this guy is still studying, right? Yeah. Anyway, he is a lawyer now. His father, his parents own, anyway, they own a supermarket chain on the Big Island, and I see him around every once in a while, and he's at the Capitol, anyway. But that was my roommate in college, pretty hilarious. And, anyway.
2 different people.
2 completely different people in that same room. Anyway, all right. So, but I did wind up once in a while staying up late. So let's not keep you up late by telling stories, and let's do some more math. But see, the stories in the middle that lowers your cognitive. It just gets you back, right? Like, oh, we're doing math. I'm scared. No, we're just doing math. All right. So now let's do this. I know. Oh, actually, I don't know what this is anymore. I've somehow gotten math amnesia, and I don't remember that's a 30-degree angle. Well, how do I figure it out? Well, I know that's 1 and 2. So here's what I'm going to do. Have you heard of this concept called arc sine, or arc cosine, or arctan? That's the archaic way of saying it. They usually use inverse tan, inverse sine, inverse, right? Okay, so that's just sine to the -1. Let me show you how you do it on this calculator for you, but and this one also. So it's just sine to the -1. So what I'm going to do is I'm going to hit shift and sine, and do you see what I get on the display?
0.
Up in the corner.
No.
What? Right there.
Sine -1.
That's arc sine.
Excellent.
All right. So now, and the way the syntax works on this one, I have to put that in first, and then a lot of other ones it's the other way around. This is actually pretty cool. All right. So now I do arc sine. Well, do I know 1 to 2? Do I have to do any math for that one? No, I can do 1 to 2 in my head, and I know that 1 to 2 is the same thing as 0.5, right? All right, so now I'm going to do sine, arc sine, 0.5. Let's see what I get. So let's see, arc sine, I'm going to put 0.5 in and hit equals. Oh, what did I get?
Oh, sine, like, arc sine 0.5 and 30. It means it turns into 30. U equals 30.
It's 30. It doesn't turn into anything. The relationship is 30.
Yes.
That's Calvin and Hobbes. You see that one? It's like, when you put two numbers together, like 3 and 5, they turn into this whole other number. 8. No. Nothing turned into anything. 3 and then 5 more is 8, right? These are the same thing. Alright, so this and that, oh yeah, it's the same thing. Oh. See it?
Oh.
Alright, so now if I have two sides, I know that angle. Right?
Yep.
And then I could come from over here, and let's see if I can get a 60 out of this calculator. And then we'll quit. So let's see, I'm standing on, get my guy, and I, go reach up. Can you reach up that high? Reach up on top of my thing right there. Yep, there, right there, the black, not there. Over one more. Yes, there's a little man on top of there. There he is, bring him here.
Two of them.
Two of them, I just need one. I used to have 3, and then your brother took one to school.
That red one. That red one was mine, too.
The red and white one.
His was that one.
Yes. Anyway, but he took that one to school, and it was stolen from him, and my poor little boy lost faith in humanity at the ripe age of 5. Anyway, because he left it in his desk, and when he came back, it wasn't there. Anyway. So, I am going to look from this angle. There's my little man, and he's looking from over here. Now, let's see here. I can use this one or that, but again, I'm trying to find this. So I have all the things I need. So I'll tell you what, I'm going to use, I don't know, what is this? This is my adjacent, isn't it?
Yep.
And that's my hypotenuse?
So you're going to use cosine.
I'm going to use cosine. So I'm going to use arc cosine, and I'm going to use 0.5 on that one, because it's the same.
Yep. And it should be 60.
It should be 60. Punch your calculator and see if that's the case. You do it. Oh, wait, here. Clear, 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 clear. Alright. And then just put in 0.5 and hit enter.
60.
What do you know? Because that relationship, and see, we're only just doing this one special triangle, but the idea is to get the concepts down, right? Because I had a student that was great. She's like, wait a minute, we use completely different and we still got the same, because the relationship is the same. Right? Because look, I could use cosine. I could also use opposite over hypotenuse, which could be sine of 60. I could, sine of the arc sine of 0.5, and I'd still get 60. I could use over here, because I know them, I could use opposite over adjacent. So here's my opposite, here's my adjacent. Right? So I could use tangent of 0.5. Or excuse me, not 0.5. Now I have to do a different relationship, right? I have to take those two numbers. So let's do it. I said we're going to quit on the other one, but just for fun. We're going to look for 60. So, all right. I use the arc tan. Well, what's the tangent? Opposite over adjacent. So now it's just square root of 3. So what was my square root of 3? 1.4. Yeah, that was square root of 2.
1.7320, I think it was.
You tell me, what was the square root of 3? It should be right in front of you.
1.7320.
There you go. Alright.
He was correct.
Punch it on your calculator and see what happens when you take the arctan of that.
Oh.
I'll do the same.
Fine, I'll just sit here.
Yeah, because you're being a dork, so.
Sad and calculatorless.
1.7320 equals. Well, we did not get 60. Darn it. What do we get? I got 59.99992. Right? So I got 4 9s after my oh no, I got 3 9s after my 59. And if I would have used more of this, I would have got, right? Right? So if I'm rounding off, I got 60.
Yep.
Do you see? And if I made this number, and see, this is fun calculator play and so forth, if I made this longer, I'd be more accurate over here.
Yep.
Right? And I have the one where you hit memory, right? So you put the full, bajillion digits of square root of 3 in there, hit memory, and you're gonna get 60.
Mm-hmm.
All right, I think that's it for class. That's just just enough to, like I said, just these little, because I see all these little pukas you have in Hawaii. That's a hole. That means hole. I see all these little holes you have, and so we just got to fill in the holes. And then the next time you take the class, ace it.
It's like a road.
Exactly.
You're filling it in with cement.
Exactly. So you don't fall into the potholes. Alrighty. Have a good night of sleep, and I will see you, when we're going to see each other again, next Wednesday morning or evening? Let me know. But just generally, you going with morning or evening?
Generally morning. I'll let you know.
Okay, but let me know. Okay, either way. I was ready to go this morning, but you were doing your study group, so we're doing it at night instead. But either one is fine. All right, thanks, man. I will have a good sleep, and I will talk to you in a week. And if you got questions or something strange comes up between now and then, shoot me an email. All right, take it easy. CrewtonRamone'sHouseOfMath.com for more. What?